Oh, what's going on, guys? I'm Johnny Brook. Welcome back to another Crafted Workshop video. This week's video, I'm going to show you how I built this super comfortable modern Adirondack chair. Let's go ahead and get started with the project.
Before we get started, I just want to mention that this video is sponsored by Burns-O-Matic, and you'll hear more about them later in the video. I decided to kind of experiment on this project with some wood I'd never worked with before, and that's thermally modified ash. So after seeing it at my local lumber and woodworking store, Asheville Hardware, I knew I wanted to use it on a project, and this Adirondack chair was really kind of the perfect choice. So thermally modified woods are essentially cooked at a high temperature, around 400 degrees, and this process makes the wood pretty much impervious to rot and bug damage. And the process also makes the wood more dimensionally stable, and all of these factors make thermally modified woods a great choice for outdoor projects, and best of all to me, there are no chemicals involved like with pressure-treated lumber. And I know this might sound like a commercial, it's really not. I just think thermally modified wood is kind of a cool new choice for outdoor projects. So anyway, after picking up the ash, I broke down the boards into their rough lengths at the miter saw and bandsaw, and then jointed one face and one edge at the jointer. And this probably wasn't necessary since these boards were already S3S, but I also wanted to bring the thickness down a bit. After jointing the boards, I ran them through the planer to bring the other face into parallel and bring the boards down to their final thickness of 3/4 of an inch. Next, I started working on the metal framework that will add some support to the arms and back of the chair, and I started with aluminum but ended up running into some issues trying to braze the aluminum, which you'll see here in a second. So I cut the aluminum to length at the miter saw and then beveled the edges and ends of the pieces with a file. And this bevel will allow more of the brazing material to be added to the joint, which in theory should make the joint stronger. So once the pieces were beveled, I cleaned them up with a wire brush, and then I could get to brazing. So I was initially going to use this awesome fireball square to hold the pieces in place, but thankfully remembered that these squares are also made of aluminum, and I definitely didn't want any of that brazing material ending up on the square. So I changed tactics and clamped the pieces together, applying clamping pressure right at the corner where I'd be brazing, which I quickly realized was a mistake.
Alright, so as you guys might have noticed, I started to have some difficulty there with the brazing. And so there were a few issues. First of all, when you're heating up the aluminum to the point where it's going to melt that brazing rod on contact, when aluminum gets that hot, it also becomes pretty pliable, especially thin-walled tubing like this aluminum. So on my first try, I had the clamping pressure kind of across the sidewalls of the tubing, and it just slowly started to squish the tubing, which obviously is not good. So I changed my clamping strategy and thought things would get a little bit better, but then the other issue I ran into is that since I really needed to braze both sides, at least both faces of this joint to make it strong enough, because I was applying so much heat to those joints, the previous joint that I had just brazed would have a tendency to just kind of open up when I was doing the other joint. No! No! I basically just decided to scrap the brazing idea and move on to a process I'm a lot more comfortable with and that I've had a lot of success with in the past, and that is copper soldering. So you guys might have seen my lift top coffee table video. That turned out great. It was much simpler, very easy to work with, and actually the copper for this build is cheaper than the aluminum in this case. So I think switching to copper is going to be the way to go. So let's go ahead and get started with that.
After picking up some 3/4 inch copper tubing, I got to work cutting the pieces to length. And this process is super simple using one of these pipe cutters, and you can get surprisingly accurate results with one of these tools. Basically, you mark the length of your piece, line up the cutting wheel with your mark, and then slowly add more pressure as you spin the tool around the pipe. And eventually the cutter works its way through the pipe and you get a nice clean cut. And I just kept cutting my pieces down until I had all of my parts, and the pieces for this build came out pretty much perfectly from a 10-foot length of tubing. Before getting to soldering, I needed to remove all of the barcode stickers from the elbows, which came off easily enough with a scraper and some goof off. To prep the parts for soldering, I first used this wire brush to abrade the surface of the ends of the tubing, as well as the inside of the elbows. Next, I applied some flux to the end of the tubing, and you really don't need a ton of flux here. After applying the flux, I pushed the tubing into the elbow, making sure it seated fully, and then wiped off any excess flux. So to solder copper, you want to heat up the joint until the flux melts, and then basically wipe the solder across the tubing until it melts and flows into the joint. And the solder will go wherever the flux is, and it will also follow the heat. On this first joint, I was applying heat to the same face I was adding the solder to, but I really should have been heating up the other side of the joint so that the solder would have been pulled around the joint. After applying the solder, I wiped away any excess with a wet paper towel, and the joint was pretty much done. And you can also see that I got a lot better as I went, and my last few joints were the cleanest, as is pretty much always the case with this kind of thing. So while I'm soldering, let's talk about the sponsor of this week's video, Burns-O-Matic. Burns-O-Matic has been the leader in the blowtorch category since 1876, providing durable, safe, and dependable products. The Burns-O-Matic TS8000 I used on this project is perfect for use on soldering and brazing jobs, and is great for bigger, larger jobs and projects that require a bit more heat like this one. And I've owned this particular torch for at least a few years now, and have used it for everything from lighting my scrap wood burn bin to popping bubbles in epoxy, and even searing steaks after cooking them in my sous vide. So to learn more about the TS8000 and Burns-O-Matic's other products, check out the link in the video description below, and thanks again to Burns-O-Matic for sponsoring this week's video. After finishing soldering, the dimensions on the support structure were set, so I could get back to working on the wooden portion of the chair. So I started by ripping the arms and legs to final width over the table saw, and after ripping the boards to width, I cut the boards to length using my crosscut table. And I've got to say, this is one of the best things I've added to my workflow in a while, and I just love the accuracy I get from it. And if you can't add a crosscut table to your table saw, a crosscut sled with a stop block built in would be another great option. So with the boards cut to size, I could get to work on the joinery for the chair, and I went with pocket holes, but if I had to make this project again, I would not go with pocket holes for these pieces. So one negative of thermally modified wood is that it tends to be brittle, so even when using the correct hardwood pocket screws, I still got a lot of splitting at the ends of the boards. And I think something like dowel joinery or dominoes would have worked a lot better on these joints. So to fix the splitting, I added some thin CA glue to the cracks, clamped them together, and then added some activator. To help prevent further cracking, I would clamp the joints together, drive the screws in slightly to mark the hole, and then take the joint apart and pre-drill the holes. And this was pretty tedious, but luckily I only had to do this at this joint where the arm connected to the front leg. When driving in the screws, I would also back them out, drive them in slightly, and repeat this process just to help ease the screws in. And the pre-drilling and this easing into the screws really helped a ton. The two arms are connected at the back with this piece that wraps around the back of the chair, and I again attached these with pocket holes, but would again use another type of joinery. And this joint actually ended up completely breaking off camera, and I had to fix it once again with CA glue. And here you can see how that copper base will fit with the finished piece, providing support to the arms and back stretcher, which they clearly needed. The next pieces to work on were the back legs, which have a parallel angle of 20 degrees cut on each end, and I made these cuts over the miter saw. Also, I should mention that I do have plans available for this project in case you're interested in building one of these for yourself. The plans include a cut list and detailed step-by-step instructions of the build process, along with a SketchUp model of the chair. And I'll have a link in the cards and in the video description below in case you're interested. Next, I marked the location of the back leg on the front and back sides of the front leg, and also marked out locations for screw holes. I used normal 2.5-inch screws here rather than pocket holes, and I think it mitigated a lot of the splitting I had. Before adding the screws, I pre-drilled and countersunk the holes, making sure to countersink the holes deep enough to allow me to plug the holes later. After pre-drilling the holes through the front leg, I clamped the back leg in place using my T-track table, pre-drilled the holes into the back leg as well, and then drove in the screws. And as you can see, I started with 1.25-inch screws here, but ended up switching to 2.5-inch screws, which provided a lot more strength. You also might notice that I'm adding the back leg to the wrong edge of the front leg, and that's because I figured it'd be easier to attach them in this orientation and then just swap the front legs, rather than trying to figure out a method of clamping them along the inside edge of the front legs. After swapping the legs, I could mark out where I needed to cut a flat spot on the back legs to get the chair sitting level. So to make this mark, I propped the front legs up on an offcut, bringing the front up 3/4 of an inch and making the front legs plumb, and then I marked a line on the back legs using another offcut. I could then just cut to my line using the jigsaw, and I cleaned up the cut with my low angle block plane. And with that, the main structure of the chair was pretty much assembled, so I could go ahead and attach the copper base. And I originally used these straps here, but ended up driving screws directly through the copper later, which ended up looking a lot better. Next, I could get to work on the back panel, and this is a simple assembly of 4 boards connected with 2 perpendicular cross supports at the top and bottom of the panels. I ripped the boards to width and cut the boards to length at the table saw, and then I could start assembling the back. I first clamped the boards together so that they were square to each other, and then laid out the location of the cross support, and I needed to have an 1/8 inch overhang on the bottom cross support to allow room for wood movement, and I set this spacing with an 1/8 inch spacer, and then glued and nailed the piece in place. And I repeated the same process for the other cross support piece, and then I could start attaching the rest of the boards. I used the same 1/8 inch spacers between each board, adding glue to the cross support and then attaching the boards with 2 screws. And I made sure to mark the locations of the screws so that they looked nice, and just worked my way across the back panel. Next, I needed to get the back panel attached to the back legs. After marking the location of the back panel on the back legs, I lifted the panel into place and then just clamped it into place. To attach the back panel, I once again used 2.5 inch screws and pre-drilled and countersunk the holes before adding the screws. With the back panel installed, I could work on attaching the last parts of the chair, which was the seat. I started by adding the frontmost seat slat, which helps the seat transition smoothly around that acute angle, which just makes the seat more comfortable on the backs of your legs. Once again, I cut the board the size of the table saw, added pocket holes, and then clamped the board in place after checking for square. After clamping the board in place, I drove in the pocket screws, and then I could start working on the rest of the seat slats. I measured the distance between the back panel and the front seat slat, subtracted 5/8 of an inch to account for the gaps between the seat slats, and then divided that number by 4. And I cut 3 of the seat slats to final width and left the frontmost piece to be cut to size later. I also installed these pieces with pocket holes, and this was a little bit tricky since I had to have the chair propped up on edge. And I added that same 1/8 inch spacer between the slats when installing them, and after getting the 3rd slat installed, I could measure for the final piece. Once again, I subtracted 1/4 of an inch to account for the gap on each side of the board, and I also took my angle gauge and set the angle I'd need to cut on one side of the slat. I set my table saw blade to that angle using the angle gauge as reference, and then set the fence to the correct width, erring on the side of too wide to start. And this is what the board looked like after ripping, with the angle on one edge and the other edge being square. So in the first test fit, the board fell through and chipped out the entire corner, once again due to the brittleness of this thermally modified ash, so again, be careful there. Anyway, after clamping the board in place and seeing it was slightly too wide, I shaved off a bit more at the table saw and then fit the board into place with a spacer on each side, clamped it, and then added the pocket screws. And with that, all the parts of the chair were assembled, so I could get the copper base removed for finishing. And before doing that, I went ahead and added the 1.5 inch screws through the copper tubing, using a center punch to mark the hole location and a metal drill bit to drill the holes. And while I do that, I just wanted to take a quick second to thank my YouTube sponsors for their continued support. Also, YouTube has finally enabled us to add different levels. Luckily, now the lowest option is $1.99, and if you want to really help to support me, there are even higher levels with even better perks, like monthly Google Hangouts with me. So check them out and let me know if there are any other perks you want to see in the comments below, and thanks again to all of my members. After getting all of the screws added, I removed the base and got it prepped for finish, and I used a file to remove any excess solder around the joints, which is a surprisingly quick process. After filing, I wiped the entire base down with synthetic steel wool to remove any surface imperfections and to allow the paint to adhere a little better. And before painting, I wiped the base down with acetone to remove any metal dust and surface contaminants. I used a self-etching primer as the initial coat to provide better adhesion for the paint, and then sprayed on a few coats of flat black paint. While the paint dried, I could finish up the wooden portion of the chair, and now that the base was out of the way, I could add pocket holes to attach the back panel to the back stretcher. And I waited to do this until now so that I didn't have to guess at the location of the pocket holes, as I wanted them to be roughly centered on each back slat to allow for wood movement. After attaching the back panel, the structure of the chair was done, so now I could get everything cleaned up. First, I wanted to plug all of the screw holes, and I tried a technique I'd never actually tried before, using a plug cutter. The nice thing about a plug cutter is you can cut plugs from the exact wood you used on the project, so the plugs basically disappear once added. And this plug cutter is from Rockler, and it worked great, and I'll have a link to it in the video description below. After cutting the plugs, I popped them out with a flathead screwdriver and added the plugs to the holes with a little bit of wood glue. After driving in the plugs, I trimmed them flush with my Japanese pull saw, which I like to do while the glue is still wet, and this allows the sawdust to work its way into any gaps around the plugs, and after a little bit of sanding, you're left with a basically seamless cover-up. And it's really pretty amazing how well this worked versus just using something like a dowel, which is what I've used in the past. And the best part is that these plugs are free once you have the plug cutter. So the only holes I couldn't plug with the plug cutter were the pocket holes, and Craig makes a pocket hole plug cutter, which would have been perfect here, but I don't have one. So I tried to use some walnut dowels to plug the holes instead, and the color match just wasn't great. Luckily, these are barely visible in the final piece, but I kind of wish I had just left the pocket holes visible. So with that, all that was left to do was get the chair sanded. And I started by sanding a chamfer onto the bottom of the legs, which will just help to keep the wood from splitting out when it's dragged across the floor. After that, I sanded the rest of the chair up to 180 grit, making sure to break all of the edges. I also hand sanded between all of the slats, which was super tedious. And with that, all that was left to do was reattach the metal base. And you might be asking, what about the finish on the wood? Well, since this thermally modified ash is so rot resistant, I kind of want to use this chair as an experiment. And it should just take on a beautiful gray patina over time, kind of similar to cedar.
Extremely loud.
And since I'm terrible at maintaining outdoor finishes anyway, I think this should work out fine. So with the base attached, I could call this chair finished.
All right, hopefully you guys enjoyed this one. I really like the way this chair came together. Again, if you do want to build one of these for yourself, I will have plans available. I'll link to those in the video description below. Also in the video description below, I'll have links to all the tools and materials I used on this project. And last, I have added some new YouTube membership levels to the channel. That gives you a lower cost option for supporting me monthly, as well as some higher options, which include some really cool perks. So hopefully you guys will check those out. And until next week, happy building.